So get this. There's a new nuclear reactor concept, and it comes from Germany, of all places. You know, the country that just finished shutting down all of its nuclear power plants. It's called the dual fluid reactor, and honestly, the promises being made are just staggering. It sounds like something out of science fiction.
Okay, so first up, let's talk about the price. The developers claim this reactor can churn out electricity for just 2.1 cents per kilowatt hour. I mean, that's a number so low it could completely rewrite the rules for our entire energy grid. It's almost hard to believe.
And then you have the safety claim, which, wow, it's a big one. The designers are saying that because of the way it's built, the fundamental physics of it, a catastrophic meltdown, the thing everyone is terrified of with nuclear power, isn't just unlikely. They say it is physically impossible.
But this might be the most revolutionary promise of them all. They claim it can run on existing nuclear waste. Now just think about what that means. It could actually solve one of the biggest, most stubborn problems of the entire nuclear age. What on earth do we do with all the hazardous waste we've been stockpiling for decades?
You just have to appreciate the irony here. At the very moment Germany is turning its back on nuclear energy, a team of researchers there is designing what they're calling a fifth-generation reactor. They're basically claiming it's such a radical leap forward, it even surpasses the fourth-generation designs that most experts are still trying to figure out. So how is all this supposed to work?
Well, the secret to all these incredible claims, it really comes down to one core idea. They've completely rethought the reactor design by getting rid of the solid parts and, well, turning everything liquid.
And here you can really see that fundamental difference. A typical reactor uses solid fuel rods that are cooled by water. But the dual fluid reactor? Nope. It dissolves the nuclear fuel into a liquid salt solution, and then it cools that with a completely separate loop of molten lead. That's the dual fluid part, and it changes everything.
Because of that liquid design, you get this incredibly simple, elegant, passive safety system. It's all just basic physics. If for some reason the reactor starts to get too hot, that liquid fuel naturally expands, right? And as it expands, its density drops, which pushes the atoms farther apart. That makes it harder for the chain reaction to continue, so the reaction just automatically slows down and the reactor cools itself off. No buttons, no computers, no human needed.
And the list of advantages just keeps going. The fuel flexibility is amazing. It can run on uranium, thorium, or, again, that old nuclear waste. It operates at a blistering 1,000 degrees Celsius, which means it's incredibly efficient at making electricity. Plus, it's designed to run nonstop for 25 years. And maybe the biggest kicker, the leftover waste is only dangerously radioactive for about 300 years, not the tens of thousands of years we're dealing with now.
But let's be real, that 2.1 cent price tag, it just sounds a little too good to be true, doesn't it? Because when it comes to building nuclear power plants, what's promised on paper often runs into a brick wall of real-world costs. So let's dig into that a little bit.
Yeah, history tells us to be pretty skeptical. This is the story of pretty much every major nuclear project ever. They start with a promised cost, but after all the delays and complications, the final bill ends up being 200, 300, sometimes 500% higher. The takeaway is pretty clear. You have to take any initial cost estimate for a nuclear plant with a giant grain of salt.
But there is a really interesting counter-argument to consider. If this reactor really can eat up existing nuclear waste, then it's not just making power, is it? It's solving a trillion-dollar multi-generational problem. In that kind of world, you could imagine countries literally paying the reactor operators to take their waste away. The electricity could actually have a negative price. It's a wild thought, but it shows you what a game changer this could be.
Now, as you've probably guessed, this isn't the first time someone's tried to build a liquid fuel reactor. And if you look back, the history of these designs is filled with some really serious technical roadblocks and, frankly, a lot of skepticism from the experts.
This quote from Edwin Lyman really nails the core of the problem. These ideas are fascinating on a whiteboard, but they are totally unproven in the real world. I mean, there's just no long-term operational data. So all these amazing promises are just that for now, promises. We have no idea how these materials will actually hold up after years of intense heat and radiation.
And the biggest monster hiding in the closet here is corrosion. Way back in the 1950s, researchers at Oak Ridge National Lab in the US tried to build a reactor like this. It failed. The super-hot radioactive liquid salt was just so corrosive that it literally ate through the reactor parts. The whole concept was shelved as unworkable. Now the team behind the dual fluid reactor says that, thanks to modern materials and new coatings, they have finally cracked this problem.
So to prove that they're right, the company is moving forward to build the world's very first prototype. But the location they've picked has definitely made some people do a double take. the Central African nation of Rwanda.
And they are not wasting any time. The timeline they've laid out is incredibly fast. They signed the deal just last year in 2023. They plan to have a demo reactor up and running by 2026, that's just 2 years away, and finish all their testing by 2028. In the nuclear industry, that's basically the speed of light.
The deal itself is pretty simple. The Rwandan government provides the land, the infrastructure, and handles the local site management. Meanwhile, the German company, Dual Fluid Energy, is in charge of all the technical stuff. Actually building and running this first-of-its-kind machine.
So the big question is, why Rwanda? Well, according to the company's CEO, it's all about moving fast. He described it as an ideal, stable, and positive business environment. And most people read that as code for it's a place where we can avoid the years, maybe even decades of regulatory red tape and public hearings you'd face in Europe or the US.
Now we have to look at the bigger picture here. While the company praises the business climate, many international groups have raised some serious concerns about the political situation in Rwanda. Reports from watchdog organizations and other governments have pointed to issues like a lack of press freedom, suppression of political opposition, and other concerns. It just adds another complicated layer to this whole project.
And that really brings us to the final, critical question. On one hand, the dual-fluid reactor could be a revolutionary technology that gives us cheap, safe, clean energy while solving our nuclear waste problem. On the other hand, it could be a very high-stakes, unproven experiment being fast-tracked in a complex political environment. Which one is it? The answer is going to tell us a whole lot, not just about the future of energy, but about how we as a society choose to develop and deploy potentially world-changing new technology.